Sauce here. This is a video lesson on factorization with variables. We mean factorization problems that contain variables. Factorization means to split something apart into its factors. Factorization means to express a number or an expression as a product, as a multiplication problem. For example, we could start with 24x cubed. That's a number, it has a variable component. This is an algebraic expression because it contains variables x. And if we were to express this as a product, we would have to find all of the factors, all of the individual numbers and variables that when all multiplied together make 24x cubed. And the way we do that is we organize our problem. We'll put the answer once we find it up at top. And we think of the ways that we can multiply two numbers to make 24. We can consider that they're branches of a tree, two numbers that make 24 when multiplied. There are a few different combinations. 12 times 2 make 24, so we can break 24 into 12 and 2. We're multiplying 24 and x cubed. We could be reminded that x cubed means x times itself 3 times. So we're listing the power x cubed as x times x times x. Now, these individual x's can't be factored further. They're like the ends of the branch where we stop. This 2 can't be factored any further because 2 is prime. There's no number that divides it evenly other than 1 in itself. So we can circle that. That's a stopping point as well. The 12 is not a stopping point because we can think of two numbers that when multiplied equal 12. There's a couple combinations, 3 and 4 come to mind. But we have to keep on going with these factors. If we can find a number that divides 3, then we will split it up. But 3 is prime. There's no number other than 1 in itself that divides 3. 4 is not prime because 4 can be expressed as 2 times 2. And we've already reasoned that 2 is a prime number, so we stop at 2. There are no more numbers to continue to factor, so the prime factorization is the product of all of the numbers that have been circled. I can list them. Typically, I start with the lower numbers. The 2's come first, and there's 3 of them. So I'm going to express the factorization of 24x cubed as 2 times 2 times 2. There's 1, 3. And then 3x factors. X times x times x. This product, if I multiplied it all together, would be 24x cubed. And the reason why we like to factor is because we can simplify algebra, especially complex algebra. If we find the factors, very often factors can be canceled with other factors that are found. So doing this is part of the process of making complicated algebraic expressions and equations much simpler to deal with. Let's do one more example. 16y to the third times t to the second, or t squared. Now I'm going to break apart the number into its factors and these powers as well. First, I'm going to deal with these powers. I'm going to think of t squared and remind myself that t squared is the same thing as t times t. Y cubed means y times itself 3 times. So I'll put its branches down here and list the y's out separately. Variables are easy to deal with when we are factoring, because these powers show us how many times we're multiplying the base or the variable, and we can't go any further. So we know that in the y cubed t squared, we simply have 3 y factors and 2 t factors. The 16 can be broken into two numbers that when multiplied equal 16, 8 and 2. 2 is a prime number, so we stop there. It's part of the factorization. 8 can be broken into a 2 and a 4. 2 is a stopping place, 4 is not, because 4 can be expressed as the product of its factors, 2 times 2. There is nothing left that we need to continue to factor, so we have the prime factorization. 16y cubed t squared is equal to, and then we'll list the numbers first, the lowest ones are best, 2 times 2 times 2 times 2, and then the y's times y times y times y, and then the t's. Being able to do this is a part of a more complex algebraic solution process in simplifying.